Hi gang! Here's a fun short science video demonstrating the Curie temperature, or Curie point, using this neat little heat engine. This black thing at the end of this copper wire is a piece of nickel metal. It's attracted to this area by these powerful magnets. But that puts it in the candle flame. Once the nickel gets hot enough, it's no longer attracted to the magnets and falls away, where it can cool off. Once it's cooled enough, it's attracted back to the magnets, and the whole thing repeats. How does it work? Like all materials, the piece of nickel metal is made up of atoms. The atoms it's made of act as tiny magnets, mostly due to electron spin, but we'll just think of the whole atoms as magnets. Another term for these tiny magnets is dipoles. In nickel, these tiny dipoles are grouped into domains. Each domain is a group of tiny magnets, all pointing in the same direction. But notice that the magnets of different domains point in different directions. That's why nickel doesn't normally act like a magnet. But when we put it in the magnetic field of a permanent magnet, the atoms in the domains now point in the same direction, lining up with the magnetic field. Now the nickel behaves like a magnet as a whole, and is attracted to our permanent magnet. We call a material that behaves like this a ferromagnetic material. But that pulls it into the candle flame, that heats up the atoms in the nickel. What that means is that the atoms start to move around randomly, but they still stay lined up with the magnetic field. And at a certain temperature, called the Curie temperature, the tiny magnets all of a sudden all point in different directions. They aren't even grouped into domains anymore, and so it no longer acts like a magnet and falls away. Until it cools again and the tiny magnets line up with the magnetic field again. Here's how I made it. To start with, I needed some nickel. I could have used other materials instead, like iron, but iron has a Curie temperature of 770 Celsius, or 1418 Fahrenheit. For nickel, the Curie temperature is only 358 Celsius, or 676 Fahrenheit, much quicker to heat up. Often people use nickel wire for this, but I didn't have any. Luckily, Canadian quarters made between 1968 and 1999 are 99.9% nickel, and looking in a roll of them I had, I found one from 1974. I started by drilling some holes in it. A whole quarter would have taken too long to heat up and then cool down, so I cut out a small piece. I then attached some wire to it. For the powerful magnets, I had these two neodymium magnets, taken from a computer hard drive. A quick test shows that the nickel is attracted to the magnets. But when I heat it above the Curie temperature, it's no longer attracted, until it cools down and is attracted again. I hung the wire from a screw and did some testing to figure out rough spacing for things. Next, I assembled this metal and wood structure out of scraps. To hold the screw in place, I put some more magnets, one on either side of this piece of aluminum, and used them to hold the screw in place. I then did something similar with the hard drive magnets. The nice thing about this setup is that it's all easily adjustable. I lit the candle, put it in place, and started adjusting things. And in no time at all, I got it working. Well, thanks for watching. See my YouTube channel, rimstar.org, for more fun science videos like this. That includes one on how a prism works to form a rainbow of colors, one all about magnetic fields with various interesting demos and explanations, and one on how to make an electroscope, a simple tool I've used a lot over the years with electrostatic experiments. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you soon.